Our sun's fate is quite fascinating. It's a story of transformation and cosmic evolution that spans billions of years. But don't worry, the sun won't become a black hole. Despite its immense power and energy, it simply doesn't have the necessary mass. It's just not massive enough for that. Black holes are born from stars that are at least 20 times more massive than our sun. You see, our sun is a yellow dwarf star. This classification means it has a relatively modest size and mass compared to other stars in the universe. Essentially, it's a giant ball of hot gas, primarily composed of hydrogen and helium. The sun creates energy through a process known as nuclear fusion. This is where hydrogen atoms are fused together to form helium, releasing a tremendous amount of energy. This process fuses hydrogen atoms into helium, which is the source of the sun's light and heat. Black holes, on the other hand, form when massive stars collapse. These stars are much larger and have a different life cycle. These stars are much bigger than our sun. They have enough mass to undergo a supernova explosion, leading to the formation of a black hole. When they run out of fuel, they can no longer support their own weight, leading to their collapse. This collapse is so intense that it creates a black hole. Now, our sun will eventually become a red giant. This is a natural part of its life cycle as it exhausts its hydrogen fuel. It will expand and engulf the inner planets, including Earth. This dramatic transformation will mark the end of the sun as we know it, but it will never turn into a black hole. The sun's mass is simply not sufficient for such a fate. The sun just doesn't have enough mass for that. Instead, it will shed its outer layers and leave behind a core. Instead, it will end its life as a white dwarf star. This is a small, dense remnant of a star's core, glowing faintly in the darkness of space. This is a small, dense remnant of a star's core. It will slowly cool and fade over billions of years, marking the final chapter in the sun's long and illustrious life. Black holes are regions of space-time where gravity is extremely strong. These enigmatic objects have fascinated scientists and the public alike for decades. Nothing, not even light, can escape their pull. This makes black holes invisible to the naked eye, detectable only by their effect on nearby matter and light. Imagine, if you will, a place where gravity is so intense that it warps the fabric of space and time itself. This warping creates a gravitational well from which nothing can escape. The event horizon is what we call the point of no return. It marks the boundary beyond which nothing can escape the black hole's gravitational grip. Once you cross it, there's no going back. The immense gravitational forces would stretch and compress any object that ventures too close. The gravity pulls everything inward, creating a swirling accretion disk of matter spiraling into the black hole. Black holes are formed when massive stars collapse under their own gravity. This catastrophic event often follows a supernova explosion. The collapse squeezes the star's mass into an incredibly small space, creating a black hole. This creates a region of infinite density, called a singularity. The singularity is a point where the laws of physics as we know them break down. The singularity lies at the center of a black hole, hidden from view by the event horizon. It remains one of the greatest mysteries in astrophysics. Stars are born in giant clouds of gas and dust called nebulas. These vast regions of space are often referred to as stellar nurseries, where the conditions are just right for star formation. Gravity pulls the gas and dust together, causing the cloud to collapse under its own weight. This process can take millions of years. As the cloud collapses, it heats up due to the increasing pressure and friction within the cloud. The temperature rises dramatically. Eventually, the core becomes hot enough to ignite nuclear fusion, the process that powers stars and makes them shine. This marks the birth of a star, a new beacon of light in the cosmos. Massive stars live fast and die young. They are much larger and burn much hotter than smaller stars. They burn through their fuel quickly, often in just a few million years, compared to billions for smaller stars. When they run out of fuel, they collapse and explode as supernovas, creating some of the most spectacular events in the universe. The most massive stars leave behind black holes, regions of space where gravity is so strong that not even light can escape. Our sun, however, is not massive enough to experience this fate. It will have a much gentler end. It will end its life more peacefully as a white dwarf, slowly cooling and fading away over billions of years. Section 4, A Tale of Two Sizes, Sun versus Black Hole. Our sun is huge. It has a diameter of about 1.4 million kilometers. However, if our sun were to become a black hole, it would be tiny. The black hole's event horizon would only be about 6 kilometers across. Imagine squeezing the entire mass of the sun into a space smaller than a city. This incredible density is what gives black holes their immense gravity. The sun's gravity keeps the planets in orbit. A black hole's gravity is millions or billions of times stronger. Section 5. The solar system's dance in the dark. If the sun became a black hole, the planets would continue to orbit as usual. This is because the black hole's gravity would be the same as the sun's. However, without the sun's light and heat, the planets would become dark and cold. Life as we know it would cease to exist. The absence of the sun's light would also make us invisible to the rest of the universe. Our corner of the galaxy would become a much darker place. Section 6. The universe's enduring wonders. Relax, the sun becoming a black hole is impossible. Our sun is destined for a different fate. It reminds us of the vastness of the universe. Black holes, while powerful and mysterious, are just one stage in the life cycle of stars. The universe is full of wonders. Did you know that black holes are not actually black? They emit a faint radiation due to quantum effects. The universe is full of surprises. Let's keep exploring.